Thank you for coming back today at our channel, The Physics Mindset. Today we are going to learn, I want students, if you're a student who is learning electrical engineering, you are an electrician already in the field, or an electrical engineer, okay? Or a technician, a repair technician, repairing electronics. Come here today. Today we are going to discuss about an essential topic which every engineer, student, technician need to know. A topic of the voltage. Now today we're going to cover what a voltage is. We're going to understand what do we use voltage and what is the voltage in particular. Okay? Now, let us see the definition of the voltage. What is voltage? If someone asks you something like, what is voltage? If you're a technician, you are an electrician. What do you think if you hear the word voltage? Check the definition. Voltage is the electrical potential difference between 2 points in a circuit. Between 2 points in a circuit, the electric potential difference. Okay? But in a simple term, if you want to really master the word voltage, it is the force. Not this, it is the force. Force. Voltage is the force that pushes electric current through a conductor. Voltage is the force, or we can call it an electric pressure. This is an electric pressure which pushes current. You know current? Electrons. They're in one place, waiting for a force to move in a conductor. Now this force is the voltage. That's why you will hear there is high voltage, meaning there is high pressure. Wherever there is a voltage, always there must be current there moving. You remember how Ohm brought up the formula whereby voltage is equals to, like this formula. Voltage is equals to current times resistance. Okay? This is the formula brought by Ohm. Or they call it Ohm's law. Ohm's law is one of the most important formulas in electrical engineering. Without this formula, a lot of problems you may not be in position to solve them when you're dealing in electrical circuits. Okay? Now, I just want you to master this term, the voltage. When current is moving slow, and that is where we say there is low voltage or low voltages. Low voltages mean there is small pressure to push the current to flow through a conductor. But if there is high pressure to push a current through a conductor, it is where we write HV, where you find when they have written HV or EHV, extremely high voltage. Okay? Now, if you see this, the term voltage, and you think of force, just think of force or pressure. You think of force or pressure. That's why when electricity is shocking you, there is that force. When you have tapped on the live wire and electricity shocks you, there is that force whereby you remove your hand very fast that force, is the force which pushes you. That is the voltage. Some people think that it is fear. It is not fear, it is the force which pushes you. You touch on the live wire, you see yourself very fast leaving the cable. That is the pressure, electrical pressure which pushes. And that is the one which also pushes electrons to flow. And it was pushing electrons to flow through you. But since you left the cable, electrons also stopped flowing through you. And the pressure which was used to push that electrons, it is what we call the voltages. Okay? Okay, take this as water. I know everyone knows water. Let me rub off this. Everyone knows water. Now, water is, let us think like we have water. I want to simplify this thing of voltage. Water, take voltage to be, take voltage to be the pressure of water. To be the pressure of water. The pressure that pushes water. Okay? You know water also moves when there is pressure pushing it to move. Now that is the voltage. Okay? Now for current, as we said with this formula, Ohm's law formula, for current, how can you, for current, to know also current, take current to be the amount of water flowing in a pipe. Okay? Current to be the amount of water flowing. Okay? Voltage is the water pressure. Current is the amount of water flowing. Is it in big quantity? In small quantity? Now that is the current. Also, pressure is the voltage is the pressure which pushes current. Whereby, is the current in big quantity or current in small quantity? It depends. But there is someone who is pushing the voltage. And this resistance, because when the voltage is pushing current, it means there will be resistance. Because if if resistance wasn't there, voltage, we wouldn't have need voltage to push current. Now we need voltage because there is resistance. Anything blocking, let us say, for resistance, to understand resistance is the blockage or the opposition of water flow. Something opposing for water to flow. The same thing happens when voltage is pushing current will be moving. Now anything which will block the current to move is the resistance. And that's why the formula, the Ohm's law formula, is voltage equals current times current and resistance. Current will be moving, it will meet the resistance, anything opposing. Okay? And this is the simplest way if you take it to be, because water is very easy to explain with, and some other people may think that what is the voltage? We are seeing voltage, we are seeing current, we are seeing resistance. Okay, but what is the things? What are the things? Voltage is the pressure. Which pressure is the pressure which pushes current? Current is the amount of electrons in a cable. I need to give, let me give you an illustration. Just one illustration so that we can understand the thing of voltage. Okay? I want to explain this clearly so that we get it. Now, check. We have our battery. This is the battery. We have our switch. This is the switch. We have our bulb. This is the bulb. And negative point goes back. It's positive, negative. Now this is the bulb. It's a simple circuit, an electrical circuit. Now, when voltage, here we say we have 2 volts. 2 volts. Inside here, in the material, there will be electrons. Electrons are on the outer shell of the atoms. This cable is made of very many atoms, and these atoms have electrons and protons and neutrons. But electrons, once they experience some force, which force of 2 volts, meaning here there are 2 batteries, meaning each battery is 1 volt, 1 volt. Okay? Now, when voltage pushes current, current 1, when voltage pushes current, or when voltage is applied, when voltage is applied in the cable, current will move from one place to another. Current will move from one place to another. This is current. Okay? Because voltage is moving with it, pushing it. Now, if it finds the switch open, current will stop here. When you close the switch, then current will move to the bulb, and our bulb will light up. Okay? Now, this bulb will act as a resistance or a resistor from the flow of current, because current was supposed to pass and it goes back to the battery like this. Okay? Now, this current was taken in the bulb, and the bulb is going to light using this current and the voltage. Okay? Now, in this flow, when talk about the resistance, when voltage was pushing current in the material, let us say these cables are made of copper. In this material, there is some resistance, the resistivity of the material, okay, in the copper wire. Voltage was struggling to push this current through the cable until it reaches the bulb, and this current is being used to light up our bulb. Now our bulb will give us some light because of the current which is brought into it by the voltage. Voltage is the one which brings the current. Okay, so that our bulb will work, and the current will be changed from electric into light. This is type of energy, transferring energy from one process to another. That is transferring from electrical energy into light energy. And not only light energy, where we use this current also from electrical energy into heat. These bulbs give some slight heat. If it is an energy saver, still it will bring some slight heat. Some bulbs are not energy savers. They will bring like filament bulbs. The element inside will heat up and creates heat. Meaning here we have another type, which is we have light energy and heat energy. Okay, but we have resistance inside. Even the bulb inside, it will create some resistance. That's why this resistance will create, when it is high resistance, heat is created. And light also is created. And this is the illustration which illustrates that the voltage is equals to current moving in the resistance. And that's why we get this Ohm's law working a lot in electrical engineering formulas when we are dealing in circuit finding problems in circuits. Okay, we are going to see some examples of how to do some workouts with Ohm's law. Okay, because it is based on the voltage, the movement of voltage, the electrical potential difference between 2 points in a circuit. And it is the force that pushes electric current through a conductor, that is the voltage. Okay, now to understand more about the voltage, we shall need to know the types of voltage we have. Okay, because we have some different types of voltage in the world, and I know you must be knowing them, but you didn't know that these are the only types we have of voltage. Let us take a look at the type of voltages. Okay, now we are going to talk about the types of voltage. Today we are covering a lesson in voltages, about voltages. Okay, now types of voltages. Types of voltage. We have two main types of voltages. Okay, one is a DC voltage. DC voltage. Two, we have an AC voltage. I know you have been knowing this. DC voltage is the direct current. Direct current. And AC voltage is the alternating current. Now, what is the difference between a DC and an AC voltage? Okay, a DC voltage, let me talk about a DC. DC voltage has one characteristic. It moves, or it flows. It flows in one direction. It flows in one direction. Okay? Like if a negative goes, it doesn't come back. Positive goes, it doesn't come back. It flows only in one direction. It doesn't return. That is a direct, that's why it's called a direct current or a DC voltages, whereby a lot of electronic technicians use mostly DC. Electronic components, they use mostly DC voltages, not AC. While, for examples, I can give you some examples of a DC voltage source. We have batteries. We have solar panels. Batteries produce a DC voltage, which is a positive and negative. Okay? And the solar panels also produce DC voltage. Okay? Which is a positive and negative. Even power banks or power banks. Power banks also produce a DC voltage to charge our phones. Okay? And these are one of the characteristics of a DC voltage. Now, what are characteristics of an AC voltage? AC voltage is the alternating current. The alternating current means it goes and it comes back continuously. It goes and comes. It goes and comes. It uses the frequency. Okay? Now, AC voltage, this flows, or it changes direction. Changes direction when flowing. When flowing continuously. It goes, then it comes. It has, let us say, this is the graph. Okay? AC current moves like this. It goes, it comes back, it goes, it comes back, it goes. Okay? This is the movement of AC alternative current. But a DC moves, let us say if this is our graph, DC moves in one, this is the voltage, and this is voltage. It moves in one direction, no changing. This is DC. This is AC. For AC goes, it comes back. Goes, it comes back. For DC, it goes one direction, no changing. Okay? And this AC voltage, this is the power we use at home. Okay? The AC voltage is the power which we use at home in our sockets, socket outlets, where we put our TVs, our refrigerators, our washing machines. That is an AC we use at home. Okay? And in the factories, industries, they normally use this AC because of it has high efficiency to carry big loads with high capacity or high wattage AC than a DC which flows in one direction. Okay? Now, to know if you know the difference between a DC voltage and AC voltage, let us say in electronics, this DC, normally in electronic we use DC voltages to power electronic components. The resistors, capacitors, transistors, they use DC. Okay? Now, but they first, let us say for a TV, our TVs, you will find our TV when they use 220 volts. That is where we plug in the socket. But after 220 enters a TV, it first enters a power supply, which converts, or a rectifier, is called a rectifier inside the power supply. A rectifier converts AC into DC. Like the logic of an inverter. Inverter changes DC into AC. But a rectifier or a diode will change a AC into a DC. And that is the power supply in our TVs. And the TVs, after rectifying this 220, a TV can be using a lot of DC voltages. You may find at 12 volts, 4 volts, 5 volts in a different circuits. Okay? And this DC, that's why DC is so important in electronics. AC is so important in our wiring of our houses, in our houses. Okay? We need this AC to light our fans, to run our fans, to run our TVs, okay? DVDs, to charge our phones. Though a phone uses 3 volts battery. A phone uses 3.7 volts, but the charger which is used to charge a phone, it is plugged in the socket. Okay? Once it is plugged in the 220 or 240 volts. For a charger, we rectify this 240 into a 5 volts. 5 volts DC. And this is the 5 volts which charges our battery inside our phones, which is rated at 3.7 volts DC. Meaning our phones, they work on the voltage of 3.7 volts. But we shall reach on these things when we start the electronics in phone repairing, okay? And you will know much about the use of a DC voltage and an AC voltage, how we deal, how the voltages help us in engineering, in any electrical engineering. Because without voltage, nothing can work. Check this. If you're repairing TVs, if you're working in a workshop, either a workshop which makes a wood workshop, any workshop, when power goes, a workshop stops, meaning voltage is so essential in electrical engineering. Without it, you are going to do nothing. Even our offices, they work on voltage. Once the voltage are not on, no office will operate because all laptops will black out. Okay? Okay, now let us see the relationship between, because this term voltage, it was the name volts as a unit of voltage was named after a scientist, Alessandro Volta. Okay, and with his experiment to make the first battery in the world, to discover, he did not even discover, he invented, because there are two words, discovering and inventing. He invented the first electric battery, and its measurement was volt. They named volt after his name, Alessandro Volta. Now, he said, we came up with what we call Ohm's law, whereby Ohm's law is current, voltage is equals current times resistance. They have some relationship. This formula has some relationship. Without knowing this formula in electrical engineering, you will miss a lot of things to solve or to repair. But the first important formula to know in electrical engineering, you need to know the Ohm's law. Voltage equals current times resistance. Let us see some of the example how you can solve some solution in Ohm's law. Okay? Let me rub off this. We want to see the relationship between the voltage, the current, and resistance. Because you can't talk about voltage, since voltage is the pressure which pushes current, and when current is moving, there is some resistance in the flow of current in the cable or in a conductor. Now, that principle, which is the Ohm's law, in electrical we can't miss talking about Ohm's law. Ohm's law. Ohm's law, which is voltage is equals to current. When voltage is pushing current, and when current is moving, it will interfere with some resistance. And that's why we come up with Ohm's law. Voltage equals current times resistance. Whereby V stands for voltage measured in volts. I will stand for current measured in amps or amperes. R will stand for resistance. Resistance measured in ohms. Symbol ohm. Now, since we have this Ohm's law formula, okay, this formula, which is so much important in electrical engineering, I've come up with a question to solve a simple question, a simple circuit problem. A circuit has a current. Note these terms. If you know the formula, we shall be in position to answer a lot of questions concerning electric circuits. A circuit has a current of 2 amps. 2 amps. Make a data if you want to. This is now to solve a problem like this. A circuit has a current of 2 amps, meaning we have our current of 2 amps. Okay? Okay. 2 amps flowing through a 10 ohm resistor. 10 ohm resistor, we have found a resistance, a resistor, meaning we have also resistance of 10 ohm. You see, a circuit has a current of 2 amps flowing through a 10 ohm resistor. Okay, what is the voltage across the resistor? Let me give you the circuit. If you want to know how to solve such a problem, you can draw it aside so that you can know what they are meaning. A circuit has a current. Let's say a circuit, we have the battery. A battery, there is a resistor. This is the resistor, okay? Then it goes back. Now, a circuit, this is a circuit, okay? Either we have a switch somewhere. Now, a circuit has a current of 2 amps. Current, let us say, current is equals to 2 amps. This is the current moving. Okay? It has a current of 2 amps flowing through a 10 ohm resistor. This resistor will be 10 ohm. Okay? 10 ohm resistor. Now, what is the voltage across the resistor? What is the voltage? Meaning, what will be the voltage which will be moving? Voltage, we don't know. And that is what we are going to solve. The voltage which will be moving through this resistor or through the circuit. By seeing this current, ohm, volts, it just sends you back to Ohm's law. Whereby, if Ohm's law is equals to current times resistance, yet we are looking for the voltage. Current is 2, because it is a current which is flowing through the circuit. Because they have told us a circuit has a current of 2 amps. This is a circuit. It has a current of 2 amps flowing through a resistor of 10 ohm. A resistor of 10 ohm. This current is flowing through a resistor of 10 ohms. What is the voltage? Since we have the current 2 times the resistor, which is 10, how much do we get? This is 20. 20 what? This is voltage. We said voltage is measured in volts. 20 volts. Meaning, here we shall be having 20 volts. You see? Meaning 20 volts. 20 volts flow through the resistor. And this is how we calculate for this simple circuit problem. And if you are doing electronics, now this is a resistor in electronics, whereby you need to know the DC voltage, you need to know the current sometimes, so that you can solve such a problem. When a TV fails to work, have this mind with you, use the formula Ohm's law, voltage equals current times resistance, then you can find out that, oh, let me calculate for the voltage, meaning if I have 10 ohm, I'll show you how 10 ohm mean it comes in to be 10. When we see the color codes, those resistors have some color codings which tell you the ohms. Some resistors are written on it that is a 10 ohm. Some they put color codes so that you just see the color. Each color has a digit it presents, and each digit, once you combine them, you will see the ohms. When we reach in electronics, we shall be discussing about that thing. Okay, now today we are on the voltage, and this is the voltage which will be passing. Now when you're measuring or you're doing some repair, after doing the formula, after calculating small calculation, then you can hold and measure for 20 volts if there is some 20 volts somewhere in electronic board when you're doing some repairs. Okay, you see how voltage is so important. Let us see another formula. In case they have given you a voltage and they want you to calculate for either current or resistance. Okay, students face a lot of this problem and they love to solve. If you master the formula of Ohm's law, all these questions will be so easy for you. Let us see another question 2. Another example or question 2. Okay, now another example to show how we are dealing in voltage, because once you are dealing with voltage which pushes current, and once the current is moving, it is facing some resistance, and that's why Ohm's law. We are using Ohm's law to solve such problems. There is another question which says that if the voltage is 24 volts, make a data. If the voltage is 24, volt is 24, and the resistance is 8 ohms. And the resistance is 8 ohms. Resistance is 8 ohms. Okay? Now, calculate the current. Oh, now we don't have the current. You see how you do your data? Now, if it is a circuit, this is a circuit, battery, our 2 batteries, we have a resistor, okay, then we have a resistor of 8 ohms. They said a resistor of 8 ohms, okay, and this is a complete circuit. Either here we have a switch, okay. Now voltage, they said it is 24 volts. Resistor is 8 ohms. 24 volts, resistor is 8 ohms. Now, what is the current? The current which is flowing through the circuit. Okay? We don't know the current. From Ohm's law, which is meaning current will be voltage over resistor. Let us drive our voltage is 24. 24 divided by the resistor is 8. Voltage is 24. Resistor is 8. Now if you chop 8, that is 3. Meaning current will be 3. 3 what? 3 amps or 3 amperes. And 3 amps will be the current passing through the circuit. Our current will be 3 amps. And the circuit, now we know all the values in the circuit just simply using Ohm's law. You need to master this. It helps us in doing a lot of solving electrical equations, electronic equations, electrical equations, and even in solar systems. You need to use these formulas all the time. I know Ohm's law is one of the most important concepts every electrician, every engineer, technician, you need to have in mind with you. Every time, at least you will apply it somewhere. When you're doing any problem solving, Ohm's law, voltage equals resistance times current. Okay? Now, since you have now some basic about Ohm's law and about the voltage, okay, that the voltage is the pressure. Now, why? We need to see why should we know that voltage. To know this topic is so much important. in our engineering professional. Okay? I'm going to show you why you need to know the voltages. Without knowing voltage, you will miss a lot of things in electrical engineering. Let us see why we need to study this topic of voltage. Let me rub off this. Okay, on the voltage, why we need to study voltage as an essential lesson in electrical engineering. Everyone needs to have this topic of voltage. Never miss it, because I'm going to show you why voltage is so much important in our field of electrical engineering. One point is voltage supplies energy to electrical devices. You see why we need to learn voltage? Because voltage, it supplies energy to electrical devices. Electrical devices like our TVs, our washing machines, our refrigerators, our DVDs, our phone for charging. Okay, a lot of electrical devices, the bulbs, they are powered or they are supplied by energy from the voltage. Without the voltage, these electrical devices can't work. The TVs, the refrigerators, they can't work. Laptops, they can't work when there is no voltage. And that's why the voltage, it is said to be an important instrument in electrical engineering. Point 2, why voltage is so important is it determines how much current flows through a circuit. It determines how much current flows through a circuit. That is voltage. How? A voltage is the pressure which pushes. When there is high voltage, if the voltage is high, meaning it will be with very high pressure to push the current. That's why it determines how much current which will flow through the circuit. You see how voltage is so important? Without the voltage, current will not flow through the circuit. And there is nothing which will work if there is no voltage. Without voltage, your TVs can't work. Our sockets, our phone can't charge without voltage, because it determines the current which flows in the circuit. Why voltage is so important is it helps engineers to design safe and efficient electrical systems. How? It helps engineers to design electrical systems like, try to see your chargers. Okay? Your chargers you plug them in the socket. In the socket is holding 240 or 220 volts. Okay? A charger, our phones use 5 volts to charge. The battery inside our phones use 5 volts to charge. Now, and it is DC, 5 volt DC. The battery itself is 3.7 volts. And the battery voltage, they are measured to be 3.7 volts DC. The socket is having 240 volts AC. Now, when you plug your charger, electrical engineers, they designed the charging circuit to step down 240 AC voltage into 5 volts DC voltage. Now, that designing of that electronic power supply is because you are playing around the voltages from 240 volts to 5 volts DC. You see how you're talking about the voltage? Voltage is helping engineers to design the efficient and safe electrical systems. Your TVs, smart TVs, they use DC. Okay? Designing those power supply, electrical design. Our bulbs, they are designed using volt. They can't work without the volt. You first supply them with the voltage, then they work. Now, another point, the last point which I like most, why voltage is so much important in our day-to-day life as engineers, as electricians, technicians, okay, it is the key. It is the key measurement when troubleshooting electrical faults. Listen this. It is the key measurement when troubleshooting electrical faults. How? When you are troubleshooting, when you are troubleshooting electrical fault, let us say a house has got a house went blackout. Some main switch breakers tripped off. Now, the first thing any engineer, any technician who's going to cover that problem, electrician, the first thing which comes in their mind is their voltage. It is the key measurement when troubleshooting electrical faults. Is there voltage in this house? The first thing to set your meter is you set it on the voltage, AC voltage, 240 volts. The first thing to look for the voltage in that house. Get a tester. Start testing if there is some voltage. That is the number one fault to start fault finding in an electrical installation. Okay? If the tester shows you that there is some voltage and you test with your meter and you measure the amount of voltage, a tester detects that there is some voltage. Or if there is no voltage, that light on the tester, just to indicate, just to show you that don't touch there is some voltage. Now for the meter, a multimeter, set it to the volt position, AC, then measure. If you want to know how many voltages are there, and that's so that you can determine why the house is not lighting up. The first thing to troubleshoot in electrical installation, you first look for the voltage. You can't look for current. You can't look for resistance. You can't look for anything. First, is there voltage? That's why we say it is a key measurement. You can't measure anything without first measuring the voltage. And once you see the voltage, then you can start doing the repair part. You will know that, oh, if I have here my voltage, this terminal has voltage, this terminal has no voltage, this position has voltage, this position don't have voltage. You can carry voltage. Once you find the voltage this side, you can carry voltage from this place to this place, and that is electricity, from moving electron from one place to another. Okay? And that is why this voltage is so much important in us, in electrical. Okay? We can't do anything without the voltage. And after knowing this topic of voltage, then it can open us to go on and in the next video and we study about power. We have studied about the resistance of the cable. We have studied about the current in the cable. We have studied about now the voltage. Now we want to study, in the next video, we shall study about power. You also need to know about what is power. Since you now know the voltage, the potential difference between two terminals, or the electrical pressure which pushes electric current in the cable to move, that is voltage. Now, what is power? In the next video, we shall start with power and we shall discuss about power. We go deep into power so that you know these terms to be used in electrical engineering. Students, electricians already in the field, and engineers, thank you for watching. See you in the next video about power. Don't miss, subscribe and like, share the video with your students, your fellow students, your friends, or electricians who are in the field, who want to know anything, some information about the voltage, about the power, anything about electrical engineering tutorials. Thank you for watching. See you in the next video.